Live from Earth, it's Space Radio. This is Paul Sutter, astrophysicist at Stony Brook University in the Flatiron Institute. And for the next half hour, your agent to the stars. We've got an amazing show ready for you today, where we talk about all the amazing things in the universe. This show lives on listener questions. We record every Thursday at 8 p.m. Eastern here at Spaceman Studios in New York City. You can leave a voicemail at spaceradioshow.com to get your questions on the air. You can also follow along with our space cadets tuning in live from around the world, including but not limited to Warsaw, Poland, Norway, Halifax, England, London, UK, Mountain View, California, Howell, New Jersey, Ferton, New Zealand, Alberta, Canada, Portsmouth, UK, Idaho Falls, Vilnius, Lithuania, Cornwall, England, Washington, D.C., Vipava, Slovenia, and coming into the last minute, Portorož, Slovenia. I have to say, I've been to Portorož. Actually, Slovenia is an amazing country, but this is not a travel show. Well, it is, but not an Earth-based travel show. This is a space-based travel show. I hope all of you space cadets out there are listening, are having a great time. Listen, we've got some amazing stuff to cover. It's been a busy week in the space universe, which is the universe. So we've got a lot of questions. We got a lot of voicemail, but we got some really, really cool news too. Guys, check this out. I want to talk about a few things coming up that have shown up in the news recently. And so as soon as I fix my live streaming software so that you can see my browser, so you can see and if you're listening to this on the radio or in podcast form, I am sorry you don't get to see the cool visuals. Yeah, so water on the moon. That's what I want to start off with today. Water on the moon. You know me in science, I'm not going to argue against legitimacy of the results like I did with phosphine on Venus, which we will get to the phosphine results. Don't worry. Here's the deal. We've long suspected that there is water on the moon, and we've seen evidence for ice water forming in the craters of the moon at the South Pole. There are regions that are in permanent shadow, and so it stays cold enough for the water to just hang out. Otherwise, if water is exposed, even as ice, on the surface of the moon, it gets blasted by solar radiation. There's no atmosphere to keep it in, and it just goes away. And so that's okay. There is water on the moon, and we've kind of known that there's water on the moon. But here's what the new result is about water on the moon. This is water found in broad daylight. And what they found, and they found this with the SOFIA instrument, which is a giant flying infrared telescope on a 747. Which is crazy because, yes, we have infrared telescopes on the ground, but the water vapor in our atmosphere, how ironic is that? The water vapor in our atmosphere is really good at blocking infrared radiation. So the infrared telescopes on the ground are really limited. They can only observe in very specific wavelengths. On the other end of the spectrum, we have orbiting infrared telescopes like the Spitzer Space Telescope, but those are kind of expensive. So SOFIA is this awesome middle ground, which is let's put it up in the air and get rid of most of the atmosphere and still be able to observe cool things. Okay, so they used an infrared telescope. They found water on the moon in broad daylight. Positives, this means, okay, water might be more accessible. And if we're trying to put people there, have a little moon base finally, which we've only been talking about for half a century now, it'd be nice to just have some water nearby so you can take a drink. You can have some fuel. You can flush the toilet. It's hard to flush the toilet with moon dust. Okay, that's not going to be a very sanitary system. So just water in general is going to be handy. Cons, downsides to this. It is little molecules, individual water molecules distributed throughout the lunar dust. If I remember right, it's 1 cubic meter of lunar dirt has the equivalent of about 1 small bottle of water in it, which is not a lot. And it's not exactly you just go in there and fill up your glass. You're going to have to take a big cubic, and a cubic meter is a lot. That's a lot of dirt. And like burn it off or filter it or somehow and get at those precious water molecules. This is not going to enable us to like run a lunar facility on the water. We're going to have to pipe the water in. We're going to have to bring the water with us. So I feel like, I don't know, am I just getting cynical in my middle ages that, or maybe I've just always been cynical, that it's just, I don't know. I'm not excited by this. And I know I don't want like every episode of Space Radio to be me blasting the news, but here I am blasting the news. And so it's not a lot of water. It's kind of cool. It's kind of exciting. I'm not going to like depend on it for making ends meet, water ends meet on the moon. I think it's just not gonna happen. The moon is indeed a harsh mistress. Now, speaking of other harsh mistresses in the solar system, remember the whole phosphine on Venus thing? Yeah. Further analysis has showed that that may have been a product more of wishful thinking rather than a rigorous analysis. The thing is, you're looking at atomic spectra. You don't have a lot of very good data. It's really wiggly. There are a lot of chemicals in the Venusian atmosphere that can mimic the same signal. And so if you want to believe the original group's result that there is a detection of phosphine in the atmosphere of Venus, you have to work really, really hard, and you have to really bend the analysis in some directions that like no sane people who do this kind of work do. And it seems like it's more of an act of fiction and wishful thinking that, yeah, it's basically just noisy, junky data. And then they massaged it enough to get this phosphine signal out, which at the end of the day was just noisy, junky data. That's the end of it. So bye for that, I suppose. There's also some news that Elon Musk has said that he's not going to follow international law when he builds his colony on Mars. So fine, whatever. Like, who expected international law to work on Mars? I don't know who is expecting that, anything different. It's going to be, I just want to know, what is he going to name the first colony? I know it's not going to happen in our lifetime. I know. But what is he going to name it? Is it going to be Elonia? Muscovia? What is it going to be? Listen, we've got some questions here that I want to move on to. Remember, this is Space Radio. This show is brought to you by you. Please go to patreon.com/pmsutter to keep this show going. Moscow, that Space Cadet, ASF Mankey, Moscow. I like that. I like it. Alonia Moscow. That is going to be it. Maybe Moscow Alonia is going to be the name. And thank you so much, Nancy Graziano. So I got a couple of voicemails that I want to get to. Let's do a voicemail now, and then I'll do some Space Cadet questions. Keep those questions coming. Thank you to Nancy for copying those over into the back channel for me. Here we go. We got a question. Now, I did preview this before the show started, and it cracked me up so much, and I just had to go with it. So just...
String theory posits that there be extra dimensions that subatomic particles can vibrate in outside of space and time. I can imagine these extra dimensions, but should I really be taking them seriously?
Wow, I wasn't expecting a question from Tom Waits, but thanks a lot. I really appreciate it. Big fan of your music. Yeah, so string theory. I did a whole series. I did the longest Ask a Spaceman series ever on this. This was, I think I did 8 or 9 episodes. in a row, each one like a half hour to an hour long, digging into the nuts and bolts and the guts, the very, very dirty guts, the gritty guts on string theory. And string theory says that when we see a particle like an electron or a gluon, what we're really seeing is some tiny little particle, tiny little string that is vibrating. And if it vibrates one way, it's an electron. If it vibrates another way, it's a gluon. If it vibrates another way, it's a photon. And then all of physics is all these little wibbly wobbly strings mushing up against each other. This only works if you try to restrict these strings to 3 dimensions. They don't vibrate enough. They don't have enough degrees of freedom. They don't have enough wiggle room, if you will, to be able to explain the plethora of physics. Like the math just doesn't work out. It's too limiting. And so in string theory, they posit the existence of extra dimensions so that these strings can have more wiggle room, and then they can potentially give us all of physics. There is a total number of 11 spatial dimensions in the latest iterations of string theory. These are tiny dimensions. These are microscopic dimensions. Every time you move your hand in the macroscopic universe, you are circumnavigating these tiny little dimensions countless times, so you don't even notice. It just feels like fluid movement up here in the macroscopic world. Physics has had a bunch of crazy ideas before. I mean, quantum field theory is way out there. It also has absolutely no experimental evidence. The theory is not complete. It's not even at the point where it can make predictions because no one's been able to solve the mathematics ever. So it's a little bit tough. And then some of the theoretical underpinnings have been called into question, are being undermined. Things here in the latter half of 2020 just simply aren't looking the greatest when it comes to string theory. That's all I'll say about that. And yes, Larry Beckham of Space Cadet, string theory, deep breath. Yes, that is whenever someone says string theory, like when I'm at a public event and people say, "Hey, Paul, I've got a question about string theory," I just go, you just gotta let it out. So we got more Space Cadet questions lining up in today's episode of Space Radio. Welcome to all the Space Cadets tuning in live. Here we go. Orson Zed is asking, if neutron stars have strangelets in them, would that matter be released by kilonova events or black hole neutron star mergers? Given the age of the universe, is it safe to say strangelets don't exist? So strangelets are a hypothetical subatomic particle mostly made of strange quarks. Whenever I talk about particle physics, I immediately start rolling my eyes because it's like gets into zoology and nomenclature right away. And it's just so Protons and neutrons are made of tinier particles called quarks. There are 6 kinds of quarks: up, down, top, bottom, strange, and charm. It's theorized that possibly neutron stars, which are just giant atomic nuclei, they're an atomic nucleus the size of a city, they're the leftover cores of giant stars, that they might contain clumps of strange matter. We're not exactly sure about that. If neutron stars, or when they go boom by colliding with each other, probably so much energy is released in those collisions that the strangelets or any strange matter is liberated. And that strange matter, if it does exist, can only exist within the extreme environments of the neutron star itself. You need those crazy high temperatures and crazy high pressures in order to allow for stable configurations of strange matter. And as soon as things go boom, they go boom. You don't have those conditions anymore. You don't get the strange matter. Edward Hinton on YouTube is asking, if a single photon is chasing a galaxy, moving faster than the speed of light, will the photon live forever if we could detect it from our point of view? Random question. So our universe is expanding. It is expanding at a constant rate, somewhere around 72 kilometers per second per megaparsec, which means for every 1 million parsecs out you go in distance from us, the expansion rate of the universe is increasing by 72 kilometers per second. That means at a certain distance, galaxies very, very far away from us are receding away from us at or greater than the speed of light. No, this is not a problem because the speed of light only applies to local physics. It only applies to things that are nearby. So if a galaxy is receding away from us faster than the speed of light and we're to shoot a laser at it, that laser will never, ever, 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 ever catch up with that galaxy. It is expanding away too quickly. That beam of light will never reach it. From our point of view, the beam of light will continue to move away from us at the speed of light because that's exactly what it does, but it will never catch up with that galaxy. And that is it. Fun questions. Campbell Duncan over on Twitch is asking, it's thought that the early Earth has very little oxygen. Why do we think that, and where do we think all our oxygen came from? Fun question. This gets right to the heart of looking for biosignatures, hunting for life on other planets. We want to know. We want to know if we're alone. We want to be able to detect it. That great interview I had last week with Peter Vischer talking about biosignatures and the early life on Earth and how to find it. That was such a fun interview. It goes right into this. So we don't think the early Earth had too much free oxygen. Oxygen is one of the most common elements in the universe. It is up there. But oxygen is super friendly. It loves to combine with other things. So oxygen is the most abundant element on the Earth by far, but it's bound up with other things. When it binds up with carbon, we call it carbon dioxide, and it makes up atmospheres. When it binds up with silicon, we call it silicon dioxide, aka dirt and rocks. Like you're standing on a giant pile of oxygen and you're surrounded by a swirling mass of oxygen. The diatomic oxygen, where it's just O2, the kind that we breathe, that is highly reactive. It's very, very easy for O2 to mix in with other things like bind to silicon or bind to carbon. So even if the Earth was born with a lot of O2, just liberated oxygen, it would quickly bind up with other things. We know that the reason that the Earth has a lot of oxygen liberated floating around the atmosphere is because of life. It's because of photosynthesis. That's why we have all this oxygen. And we need the photosynthesis game to keep going in order to keep all that oxygen out there in the atmosphere. If we were to stop, if all the plants were to die, eventually the Earth would lose its juicy, oxygen-rich atmosphere. So that's why oxygen is such a promising candidate as a biosignature. If we see loads of oxygen in an alien atmosphere, that's going to be a pretty good bet that that planet might just have some life. Not guaranteed, but it's going to be nice. Assuming we get the analysis right. Isn't that right? Phosphine. Tom Vassos over on YouTube. I love the new format of Space Radio. I get to answer more questions in a half hour. I get to chat with you more. I still do the silly cheese segments. I'll still do blue shifts here and there every once in a while. But it's a lot more fun. So Tom Vassos, if we assume for a moment that the universe is flat, which all observations indicate that the universe is flat, so that's a very nice assumption. Does that mean that the universe was also infinite in size at the time of the Big Bang as well? Okay. The universe is flat. Within our observable bubble, remember, we can't see the entire universe. Our universe is gigantic. We can only see a limited portion of it because there's only been so much time for the light from distant parts of the universe to reach us. Our universe is only 13.8 billion years old. And so we can only see out to a certain distance. And because of the expansion of the universe, we can see out to a radius of about 45 billion light years. Our observable patch is ridiculously flat as far as we can measure it. Flat, 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 which just means parallel lines stay parallel. They don't intersect and they don't spread away. It's just, that's what all it means. As to what the whole entire universe is doing, we don't know. It could be infinitely big and just flat. It could also be in different shape. It could be closed like a sphere. If you think about, like, the Earth is curved, but my backyard can be flat. Because my backyard is so small compared to the great expanse of the curvature of the Earth that it looks flat here. So our little patch of the universe is definitely flat, and that could mean the whole thing is flat, or the whole thing is just big and very gently curved. We honestly don't know, and there's a very good chance that we'll never know, because these kinds of observations would be outside of observations. These kinds of observations would be outside of observations. Yeah, because if it's outside of the observable universe, by definition, you can't see it. Let's get another question in. We got Patrick over here. Here we go.
Hello, my name is Patrick Del Vecchio from Connecticut. My question is, why do astronomers assume that the Big Bang was the only Big Bang, and that it isn't just, a cycle of many Big Bangs that happen? And while it may account for 99.9999999 whatever percentage of the mass of the universe, perhaps there's some remnants of the old universe, and the Big Bang is just a result of when enough black holes merge in, deep time, the cycle of the universe ends, and there might be some remnants of, the universe before, if we looked hard enough. Thank you. Have a great day.
Thank you, Patrick from Connecticut. I will have a great day. And that is a really, really fun question. And you're not the first person to ask, is our Big Bang the only Big Bang? Have there been other Big Bangs before this Big Bang? Will there be other Big Bangs in the future? We only know of this one Big Bang for sure because we're living in it. We're living in the universe that is a part of the Big Bang that resulted from the Big Bang. There are hypothetical ideas that say that there may have been chains of universes with one Big Bang leading to another, or nucleation, like little fireworks going off, and then the one universe forms and then it fragments, and on the outer boundaries of that, new universes pop, and then they get spread apart, and there's this infinite chain of universes that go on to infinity. Something resembling what you are talking about is presented by Roger Penrose, Sir Roger Penrose, Nobel Prize winner, who his favorite idea is called conformal cyclic cosmology, where our Big Bang is just one of an infinite chain of Big Bangs, where eventually into the far future, a empty, rapidly expanding universe eventually evolves into its own Big Bang through various complicated mathematical hand waving. And over the years, Sir Roger Penrose has put out some papers claiming to see evidence for relics from previous universes appearing in, say, the cosmic microwave background. Nobody believes those results. He claims to see anomalous signals in the cosmic microwave background that no one who actually studies the cosmic microwave background sees. No one believes that the analysis is legit because the analysis is not legit. All attempts to identify relics from a previous universe or previous Big Bang in our universe have come up short. It doesn't mean it's not true. It doesn't mean some things like conformal cyclic cosmology aren't true. It just means we have no evidence for them. If you don't have any evidence for it, you don't need to bother believing it, even if it's true. Welcome to scientific positivism. I need some cheese, guys. Don't worry, the show's not over. I'm going to keep answering questions, but I'm also going to introduce and munch on some cheese because science makes me hungry. David Faster is saying CMB is kind of low resolution. Oh, man. And I can say this because I worked on the Planck collaboration, the Planck satellite. We mapped the CMB. There's so much data there. It is not tapped out. We have way more information from the cosmic microwave background. And I just had a great interview with not Brian Corbeline. He's a good friend of mine. With Brian Keating, author of Losing the Nobel Prize. He interviewed me for my book, How to Die in Space, which buy my book. Oh my gosh, I don't have a copy here on my desk. I meant to bring one. How to Die in Space. Go to pmsutter.com/book. You can get autographed copies. I have autographed copies available, or you can just go to Amazon or Barnes & Noble. You can get in bookstores, available nationwide. I've had great pictures, great comments from people picking up the book nationwide. As I'm opening this piece of cheese, guys, I got some Androulis Baltic-style farmer's cheese. And the flavor is plain. So you know what? I figure if I'm going to go for a Baltic-style farmer's cheese, I'm going to go for, I don't want any frills. I don't want any herbs or accoutrement. I just want to experience the Baltic-style farmer's cheese. It is crumbly like a farmer's cheese ought to be. It's like the kind of cheese you can make at home because it's pretty straightforward. You just need like milk and rennet and heat. You don't need to actually do a lot. As I'm eating this cheese, I will ask and answer a question from Al Nalam on YouTube. Is there a difference, Dr. Sutter? Thank you for using the correct title. In what are water molecules and ice crystals? I've always been of the opinion ice is such frozen H2O, or I need some education. Ice is frozen. Ice in general in astronomy can mean many things. Basically anything that's normally liquid but is not and is currently frozen. Water is one example, and it is just frozen H2O. They arrange themselves in very interesting shapes that lead to all those cool crystal structures. But let me try this Androulis Baltic style farmer's cheese. Was this made in Atlanta too? Oh, it was made in Michigan. It's good. It's good farmer's cheese. You will not be surprised by the fact that I've dabbled in cheese making. Farmer's cheese I like making. This is a good one. It does have a slightly different tang to it. It's almost like a mix of farmer's cheese and like a good feta. Good job, Baltics. Estonia, Finland, whoever you are. Larry Beckham is wondering, can I autograph my Audible copy? Sure. Mail me like your car stereo or your smartphone. I'll autograph the thing. I'll mail it back. Kevin is asking, could you do TOE? I'm guessing that's Theory of Everything one day. We do not have a Theory of Everything. We don't even have good contenders for Theories of Everything. Larry's saying, I love listening to Paul's book. And Paul's like, yes, I got to narrate the audiobook for How to Die in Space. I auditioned for it. I got it. I spent 4 days in my closet with the director on Skype recording that sucker. That was a lot of fun. Okra cheese. But I must try Mercy Valley cheese. Hey, send me some. Send me some. I'll eat it. No, don't send me food. That's probably weird and dangerous. That's probably not. I will not try hemp seed cheese. Mark Starkiller is asking, about the water on the moon thing. How's it possible? Isn't the temperature on the moon about 160 C in the day? Yeah, exactly. It's hot. We suspect that these water molecules do eventually evaporate, go out into the vacuum, but then they're replenished. So they're like being carried there by the solar wind or something. Like something is sprinkling water dust. And I'm still eating this cheese on the moon. One more question before we go. One more question. Paul Gilligan, YouTube, what is space-time? Is it just all the subatomic fields properties combined, or is space-time its own thing? It depends on who you ask and what kind of problem you're doing. The vast majority of problems that we encounter in physics, space-time is just the coordinate system. It's just the stage on which we do all the interesting things of physics. But in general relativity, the stage itself is an actor. Space-time is an entity because changes in space-time are what we call gravity. Space-time itself responds to the presence of matter and energy. And then the deformations, the bumps and wiggles in space-time influence how matter and energy move and behave. So it becomes its own character. It becomes its own entity. And so it's like watching a play where the stage is alive. I know. This is good cheese. I would buy more Baltic-style farmer's cheese. I would sprinkle it on a salad and convince myself that I'm eating healthily. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Visit patreon.com/PM Sutter to learn how you can contribute. Thank you so much to Nancy Graziano for producing this show and wrangling the Space Cadets. Catch the live stream every Thursday at 8 p.m. Eastern. Go to spaceradioshow.com for more info. Also go to pmsutter.com/book. Buy yourself a copy of How to Die in Space. Thanks again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission. That's it, folks. I am going to smash some more of this cheese into my face. And I'll see you guys next week.